Does everybody agree that in order to solve this problem, you need to put it into a form that you recognize, right? We haven't factored anything with x's in the denominator. Okay, so Joe suggested one way that works. Okay. There's another way that's very similar to that, but it eliminates the use of division. Okay, and it just keeps it as a single or as a fraction. And the way that we can do that is, what would it take to get rid of all the denominators of these three terms? What would you have to multiply by? X squared, right? If you multiplied each term by x squared, you'd eliminate all the denominators completely. What about in the denominator here? What would you need to multiply by to get rid of all of these? Again, just x squared, right? So the LCD of every factor or every denominator involved in this, the top or the bottom here, is x squared. So if we multiplied by x squared over x squared, does that change the value of our fraction? Because x squared over x squared has a value of what? 1. So multiplying by 1, it's called the identity property of multiplication. It's not going to change the number. So if we take each of these expressions and we multiply by x squared, okay, what do we get in the first term here? X squared. What do we get as our second term here? Minus 5, and then one of the x's cancels here, leaving an x. And then what do we get as our last term? 24. Okay, and that's all over. Now remember, all of these denominators cancel. So now we move to the bottom and we distribute this. So 1 times x squared gives us x squared. 8 over x times x squared gives us 8x. And then finally, 15 over x squared times x squared gives us 15. Okay, so we've now eliminated our fractions. We've simplified what we're working on, and now it just becomes this simplified problem. So when we simplify this, it's the same factoring that we did. Okay, x minus 8, x plus 3. Here, x plus 5, x plus 3. We're still going to simplify to cancel our common factors. And we're left with our answer, x minus 8 over x plus 5. Same answer. And now, here's the thing that starts to come into play. And it's especially when we start talking about dividing and not just multiplying. But it's really true of all. When you're looking for those additional domain restrictions, you have to refer back to the original form. Now, when we go back and look at what factors get canceled, that's part of referring back to the original form. So we see here x cannot be a negative 3. Is that shown or apparent in this simplified form? No, so we do need to include that. So that's one of our restrictions. Okay, but we also need to go back and again, look at the original form. Were there any other restrictions from the original form? What do you see here? X cannot be 0. So you do have to refer to that. Is that restriction apparent in this simplified form? No, so we have to include that as a separate restriction.